Hello everyone. So today we'll see about thin and thick cylinders in strength of materials, and this is one of the easiest chapter, and questions are asked from these chapters in competitive exams as it is easier to solve and less time consuming. Don't skip this portion for competitive exams. So first let's understand what is a thin cylinder and its concept, how the cylinder is going to burst when subjected to the fluid pressure, the related concepts we're going to see today. So let's start. So we know about boilers. So boilers, the shape can be cylindrical shape or spherical shape. Boilers are used for storing fluids. Fluids can be liquids and gases. So these are used for storing fluids under pressure. Okay. So in case of thin cylinders, the walls are very thin compared to its internal diameter. That is, the thickness of wall is less than 1/15 to 1/20 times the internal diameter. Okay. And the stress distribution is uniform throughout the thickness of the wall. Okay. Now let's see about thin cylinders subjected to internal pressure P. Okay, how it's going to burst. Consider a cylinder. Okay, and now the fluid pressure in a cylinder, the fluid pressure is acting throughout the circumferences on the wall and also the two circular portion at the end. To that also the pressure is acting. So throughout the circumferences and lengthwise the pressure is also acting. Okay, so first case, the cylinder will consider the pressure which is acting along the circumferences. That is, along the circumference of the wall the pressure is acting. Okay, like this. The pressure is acting like this throughout the circumferences. Now when a cylinder is subjected to pressure throughout the circumferences, let's take a cylinder and we are looking from here, and the pressure is acting on top and bottom of the cylinder throughout the wall. Okay, then how the cylinder will burst? Like this. The cylinder, if it's like this, it will burst like this. Burst like this due to the pressure acting up and down. Okay, this is the pressure P acting towards up and down. It will get separated along this line. Cylinder will get separated into two parts. Then when this pressure is trying to burst the cylinder like this, through the thickness of the wall, that is where it will get separated. When a cylinder gets separated, we can see top two lines and bottom two lines of cylinder. Top two lines here and backward, bottom here and backward. So through that thickness of that line, from which it gets separated into two parts, total 4 lines. Okay, through that thickness the stress will act in opposite direction. That is, bottom portion the pressure is acting downwards, that is why it is getting pulled downwards. Then the pressure is acting up, the stress to resist that pressure is acting upwards in the bottom portion. Similarly, in top portion, as the pressure is acting upward to separate that upward, to resist that pressure the stress is acting down throughout the thickness of the wall. Okay, thickness means here when it gets separated, and when we are looking from top, the cylinder gets separated like this. Okay, and when we are looking from top, we will see a rectangular portion. Inside is hollow, we will see a rectangular portion due to which it got separated. That is the length L and dia D. Okay, below is like a semicircle. This is the rectangular portion. Suppose we take this portion and we are looking from top, we will see this rectangular portion of length L, dia D. This is internal dia, inside to inside dia, and this is the thickness of the wall T. Okay, so consider this bottom portion. Okay, So pressure, I told it's acting downward throughout the circumferences. So when we are looking from top, on that rectangular portion, the pressure is acting downward. On that rectangular area, the pressure is acting downward. And stress, that is the stress to resist this pressure is acting upward. That is throughout the thickness of the wall, it is acting upward. Okay. This is the first case. Now suppose the cylinder, this is the cylinder, and it is getting separated like this due to the pressure acting like this. Pressure is acting like this, and due to that the cylinder is getting separated. Okay, pressure is acting like this and the cylinder is getting separated to two parts. So consider this portion, pressure is acting like this. So the stress to resist that is acting throughout the thickness. Like when it gets separated like this, when we look from here, it will be like a circle. So throughout the thickness of that circle, inside it will be hollow. So throughout the thickness of the circle, stress will be acting in opposite direction to that pressure. Okay, in this, the pressure is acting like this. That's why it is going this way. So here when we are looking, it is a circle, and throughout the thickness of the circle, inside it is hollow. So throughout the thickness of the circle, to resist this pressure, the stress is acting like this throughout the circle, thickness of the circle. So when you are looking from here, I told it's like a circle of thickness T, and diameter, internal diameter is D. Okay, this is the portion which I have shown like this. The pressure acting inward throughout this circle area. Okay, when we look from here, it will be a circle which thickness T, and inside it will be hollow, but we are looking from here, this solid portion we can see. So it will be like a circular area. So this pressure is acting in this circular area actually. Circular area. Here the pressure was acting. The top we looking, this thickness T will be there, inside is hollow, but bottom like this solid portion is there. So we are getting a rectangle. So that pressure is acting on that bottom portion, rectangular area we are seeing. So that pressure is acting in a rectangular area. Here the pressure is acting in a circular area. There the stress is only acting along through this thickness. Okay, circumference, thickness. This is pressure is acting in an area. This is along the circular length the stress is acting. So this is the main concept.